Welcome back to Lions and Academy. This is our second lecture of the first chapter, that is the basics of mathematics, and we'll have a look at the trigonometric ratios in this video, and we'll try to look at the things from a different point of view. And in this chapter, we'll not focus on mere memorization of formulae. Rather, we'll try to derive almost everything on our own. This will help us understand other chapters of physics in better way, and also there will be no need for you to mug up the things. And that's our objective here. So let's get started. Trigonometry. It's the combination of two roots, trigon and metry. Let's start with trigon. Is this word familiar to us? Actually, we know its entire family, but we have neglected the trigon. You don't believe me, do you? Let me introduce you the other members of the family first. We'll start with the pentagon. Here, penta means phi and gon means corner or angle. We know a pentagon as a phi-sided figure, and that's also correct. Another member is hexagon. Hexa means six and gon means corner or angle. And we also know it as a six-sided figure. Then comes the heptagon, a seven-angled figure. Similar way, we have octagon, an eight-sided or eight-angled figure. And we have many members in the family, like there's decagon for 10-angled figure, there is dodecagon for 12-angled figure. But our hero here is the trigon, where tri means three and gon means angle. So trigon means a triangle. And all these family members have a common name known as polygon, where poly means many and gon means angle. So the next term is metry, which means measure. So trigonometry is simply the measure of triangle. And in trigonometry, we'll study the relation between the sides and the angle of a triangle. And we'll study that in detail in this chapter. The triangle. Generally, when we see a triangle like this, we think one side as the base of triangle and the other side as the height of triangle. But in trigonometry, we know them by other names. One is called as the adjacent side and other is called as the opposite side. These terms, adjacent side and the opposite sides, are relative terms, or in other words, their position is relative. But how? Assume this triangle and this is the angle theta. Now I want to give a name to the side BC. To decide the name, we see that what's its relation with theta. And with theta, the side BC is opposite to it, hence known as the opposite side. Similarly, with respect to theta, the side AB and AC both are besides angle theta. Now, which side exactly is the adjacent side? To avoid such confusions, out of these two sides, one side we call as the hypotenuse. The side AC is the hypotenuse here. There are two ways in which we can identify the hypotenuse. The first one is the side opposite to the right angle is the hypotenuse. And the second one is the longest side of the triangle is the hypotenuse. The remaining side is the side AB, which is besides the angle theta. And the technical term for the besides is adjacent. Finally, we have BC as the opposite side and AB as the adjacent side. Now take another angle and name it as P. Now the side BC is not the opposite side anymore. The side BC is besides the angle P, therefore it's the adjacent side. Similarly, the side AB is now the opposite side with respect to the angle P. Take the same triangle, but as a first case, only consider the angle theta. Take all the possible ratios of the sides in this right angle triangle ABC. Firstly, take the side BC and divide it by side AC. Note that the side BC is opposite side and the side AC is hypotenuse. Then another possible ratio is the side AB divided by side AC. Again observe side AB is adjacent side and AC is hypotenuse. And side BC divided by AB is also possible. Here side BC means it is the opposite side and AB is the adjacent side. And that is with respect to angle theta. Now you may think you have covered all the possibilities. Think again. We can take reciprocals of all these ratios which we have written just now, and that is side AC divided by side BC, then side AC divided by side AB, and lastly side AB divided by side BC. So we have written all the possible ratios of the sides. What next? So in many different centuries, from many different parts of the world, different mathematicians have named these ratios. And we are going to see those same names which were given by them and used by everyone even today. This very first ratio right here is known as sine of theta. The second one is known as cosine of theta. The third one is known as the tan of theta. And these reciprocals are known as the cosec of theta, sec of theta, and cot of theta. You must have observed I am taking these names with theta only. For example, sine of theta and cosine of theta. And you must take a note of it. Because these terms sine and cosine means nothing if we don't combine it with angles. If we take another example, let's say we want to take the log of 10. So while writing or while saying, we'll say the log of 10. We'll not say just log because log of something has some meaning. But just the term log, what meaning it could have? Going forward, we see this triad on the right is just the reciprocal of the triad on the left. So naturally in mathematics or in physics, this second triad is often neglected and almost all the work is done using the first triad only, which is sine of theta, cosine of theta, and tan of theta. We also have one famous mnemonic device for this ratio, that's SOHCAHTOA. S is for the trigonometric ratio sine, O is for the opposite side, and H is for the hypotenuse. Similarly, cos is adjacent over hypotenuse and tan is opposite over adjacent. And you must have guessed by now why taking an angle with trigonometric ratios is important. Because the names of these sides are position dependent. That is, they are changing with the position of angle. And now take a moment and observe how things are changing with respect to phi. Observe the side BC has now become the adjacent side and the side AB has become the opposite side. So sine of phi is side AB over AC, that is opposite side over hypotenuse, and cos of phi is the side BC over AC, that is adjacent side over hypotenuse, and the tan of phi is AB over BC, that's opposite side over adjacent side. Using trigonometry, we can either know the unknown angle or unknown side. So in this numerical, we don't know the adjacent side, which is denoted by x. The unknown side x is adjacent because it is besides the angle 45 degrees. And also we know the value of hypotenuse, that's 100 units. One would think he has to find the adjacent side and he has the hypotenuse, so better use the cosine of the given angle. Therefore cosine of 45 or cos of 45 is equal to x over 100. Therefore x is equal to 100 times cos of 45. Either we remember this value of cos of 45 from a table, or we can use a calculator here to get it. But for now, we'll skip it and we'll take a pause here before having that final answer, and we'll figure out this value and all other such values on our own, like an ancient mathematician would have done it. In the second numerical, one would think that he has to find an angle and he has the opposite side and hypotenuse, so better use the sine of the angle. Therefore sine of theta is equal to 50 over 100, and that is equal to 1 half or zero point 0.5. Therefore theta is equal to sine inverse of zero point 0.5. Again, we can get the value from the table or from a calculator, but we'll leave this problem here and we'll come back to this problem later. So far everything looks good, right? But there is a problem with the trig ratios. We have defined them for an acute angle in the right angle triangle. But what about other angles, like obtuse angles, where theta is greater than 90 degrees? What about reflex angle, where theta is in between 180 degrees and 270 degrees? And what about boundary angles, where theta is 0 degrees, 90 degrees, or 180 degrees? And to address all these problems, we need to have a bigger definition of these ratios, which can address all the possible angles. And we shall see that in next video. I hope this was informative for you, and I would like to thank you for watching.